All right, this is the review for the 2.6 quiz, which is over rational expressions, equations, and inequalities. Make sure that part of what you're doing is paying attention to which type of problem it is. I'm not going to mix them up for the quiz, but oftentimes people will do inequalities the same way they do equations, and that's not quite right. So, simplify each expression means factor, cancel, combine as much as you can. So for this first one, I'm going to begin by factoring out a GCF from the top and the bottom. So I can take a 3 out of the top. And I can factor a 6 out of the bottom. You are allowed to reduce 3 over 6. That's 1/2. And then we need to keep factoring these trinomials. So there's just a 1 up here, so I don't need to write any number. This is going to be x plus 2, x minus 1. Down here, there is still a 2 because remember 3 over 6 was 1/2. There's a 2. And then this factors into x minus 1, x minus 1. And what else can we cancel? We can cancel one of the x minus 1s in the bottom with 1 on top. And so I'm left with x plus 2 over 2 times x minus 1. Remember, we are leaving denominators in factored form. There's no reason to distribute the 2. And we're factoring as much as we can in the numerator so that we can cancel factors if possible. Okay, second one is, again, always look for GCFs. So for this problem, I'm noticing it's 2x cubed. I can factor an x out of the top. That will make it 2x squared minus x minus 6. There's no GCF in the bottom, and it's only quadratic, so I think I can start factoring it. 2x and x. I need to break up 6. My options are 6 and 1, or 2 and 3. I'm trying to get 7 in the middle. Remember, whatever you put out here is going to get multiplied by 2. So if I put 2 out here and 3 right here, that gives me 4x on the outside, 3x in the middle. That's going to give me 7x. If they're both minus, it'll give me negative 7x. You've got to work on practicing trinomials. Some of you that really get stumped on your trinomials, and the only thing to do is practice. So remember, you can come into office hours, and I can go through a couple of different ways to factor them. All right, so let's keep factoring the top here. So 2x squared, again, has to be 2x and x. I'm trying to get negative 1 in the middle. I've got to break up 6 again, and whatever I put out here will get multiplied by 2. So if I do 2 and 3 again, 4x on the outside, 3x in the middle. So plus 3x minus 4x will give me negative x that I want. All right, and then everything is factored. So now what can we cancel? We can cancel out this x minus 2 with this one. And that's it, because 2x plus 3 is not the same as 2x minus 3. So my final answer is x times 2x plus 3 over 2x minus 3. You can distribute the x through if you want, but there's no reason to. Number 3 is a multiplication problem. So we're still just trying to factor as much as we can and see what would cancel. So let's start with this first trinomial. So x squared gets broken up into x and x. We need to multiply to negative 3, so 3 and 1. And it has to be plus 3 and minus 1 to get positive 2 in the middle. X squared again is x and x. Factors of 3 have to be 3 and 1. This time I'm trying to get negative 2x in the middle, so it has to be minus 3 plus 1. I'm dropping the parentheses. I'm just going to show a little multiplication symbol here. Remember, backwards factors, you want to set them right by factoring a negative out. You don't have to do that, but it just makes it a little more obvious that this 3 minus x does cancel with x minus 3. It's just that canceling really means they divide to either 1 or negative 1. So in this case, they divide out to negative 1. 3 plus x is the same as x plus 3. There's nothing to factor out of that to make that happen, so I can just write it as x plus 3. That's the commutative property of addition. And then we start canceling things. So like I said, this x plus 3 and this one, this x minus 3 and this one, you have a negative left behind. And x minus 1 does not cancel with x plus 1. So I'm going to keep the negative sign out here, times parentheses x minus 1 over x plus 1. All right, for number 4, this is a division problem. It's this fraction divided by this one. So let's just start factoring again. So 2x squared has to be broken up into 2x and x. The only factors of 2 are 2 and 1. And you have to put 1 here and 2 here, because if you put a 2 here, you would have been able to factor a GCF out, a 2, and that's not the case. Right? And then what about the signs? I'm trying to get negative 3x. So I have to make this minus to get negative 4x plus 1. So plus 1x will give me negative 3x. X plus 1, x minus 1 for the difference of squares. And then down here, 2x and x. Again, break up 2. It has to be 1 and then 2, because you can't put a 2 with a 2x if there was no GCF. And then because I'm trying to get 5 in the middle, if these are both plus, I get plus 1x plus 4x. That's where the plus 5x comes from. What about the denominator? X and x. Factors of 2 are 2 and 1. I'm trying to get positive 1x, so plus 2 minus 1. Once you get this all factored, remember it's this fraction divided by the bottom fraction. So we're going to keep the top fraction exactly as it is. I'm just copying it down. So here's the top part. And now we're changing this to, instead of a division problem, we're changing this to a multiplication problem. So we need to flip, multiply by the reciprocal of this fraction. So now x plus 2, x minus 1 is on top, over 2x plus 1, x plus 2. And we're just looking through to see what can cancel. So I see 2x plus 1, 2x plus 1, x plus 2, x plus 2, x minus 1, x minus 1. So a lot of stuff canceled. I'm left with x minus 2 over x plus 1. You've got to be careful. You've got to write neatly on these. It's really easy to misread your own handwriting if you're kind of scratching it everywhere and not being organized. So just slow down on these and be careful. All right, number 5, we are adding and subtracting. So I want to look at what the common denominator could be. If you see anything that could factor it to see what you're working with. So the denominators are x, x minus 1, and x times x minus 1. So the common denominator is x times x minus 1. And we need to multiply each fraction by whatever it's missing to get that common denominator. So 2 gets multiplied by x minus 1, top and bottom. That's going to be 2x minus 2. 3 gets multiplied by x, top and bottom, to get its common denominator, so plus 3x. 4 already has the common denominator, so no adjustment needed. This is minus 4, so minus 4. Right, and then this is going to be 5x minus 6 all over x times x minus 1. You can't factor the top any further, so nothing's going to cancel, and that's my final answer. For this one, I can factor here a little bit, x minus 3x plus 2, and that's a good sign because those are the other two denominators. So when you're setting up the common denominator, you've got to have x plus 2 and x minus 3. The first fraction already has that, so I'm just going to copy down x. The second fraction needs to get multiplied by x minus 3. Remember, it's a negative 1 times x minus 3, so minus x plus 3. This minus 2 over x minus 3 needs to get multiplied by x plus 2, top and bottom. So that's going to be, again, negative 2 that you take through there, so minus 2x minus 4. Combine like terms, so x minus x cancels out, that's 0. We have a negative 2x left. 3 minus 4 is negative 1 over the common denominator. You could factor a negative out, but that's not going to help me cancel anything, so I'm just going to leave it as it is. All right, complex fractions. So remember, there are 2 ways to do this. The LCD way is usually the fastest. It's worth practicing. Or I'll show you the traditional way as well. LCD is take a look at the denominators you have, which they're both just x plus 1, and multiply by that least common denominator on the top and the bottom. When you do that, you multiply it to each term. So what do we get when we do that? Well, 1 times x minus 1 is x minus 1. This is what's happening in the top, by the way, x minus 1. And then 1 over x minus 1 times x minus 1 is just going to be plus 1. In the denominator, 1 times x minus 1 is x minus 1. Minus 1 over x minus 1 will cancel and leave you with minus 1. All that's left in the top is x. All that's left in the bottom is x minus 2. If this confuses you, you can stick to the traditional method. The traditional method is pretty much the same math. It's just that you're keeping the denominators till the end. So the traditional method is work on this addition problem first. So let's change 1 to, well, let's get a common denominator of x minus 1. And 1 gets multiplied by x minus 1. And then you add to that the other fraction, which already had the denominator, so plus 1. Do the same thing in the bottom. The common denominator down there is x minus 1. 1 gets multiplied by x minus 1, and then you have this other minus 1 in here. And then we clean things up. X over x minus 1 over x minus 2 over x minus 1. And then we change this to a multiplication problem. So flip the bottom. The x minus 1's cancel, and you get to the same answer. So I like the LCD way better because it's less writing, and I have less chance for mistakes. Like a lot of times I'll see students that flip the wrong fraction, or they don't flip the fraction on the bottom, or whatever. So, it's worth a try. On this problem, I'm looking at the denominators. I'm going to factor this one into x times x plus 2. And I'm going to start with LCD. So what is the least common denominator out of the 3 that I see? So I have to have x. I have to have x plus 2. And there's nothing new in the bottom. It has both of those things. So that's what we're multiplying by, top and bottom. Multiply this to each part and see what you're left with. So 1 over x plus 2 will cancel with x plus 2. It'll leave you 1 times x. 1 over x, minus 1 over x, the x's will cancel. You'll be left with minus x plus 2. Be careful, it's in parentheses there. In the bottom, the x and the x plus 2 cancel, and you're just left with 3. So again, this is nice and easy because you just distribute. And x minus x is 0x, and then negative 2 over 3. If you prefer the traditional method, that would look like this. I'm working on the top to begin with. I'm trying to add 1 over x plus 2 minus 1 over x. So I'm going to set up a common denominator of x times x plus 2. The first fraction gets multiplied by x. The second fraction, the negative 1, gets multiplied by x plus 2. I can clean that up in a minute. The bottom is already one fraction, but I'll show that the bottom factors a little bit. So then distribute this through x minus 2, so negative 2 over x times x plus 2. And then instead of dividing by this fraction, you multiply by x times x plus 2 over 3, and you're left with the same thing. So you can see traditional is not bad. It's not 10 more steps or anything. It's kind of about how much you write. But, I think most of the time, 99% of the time, this LCD is a little more streamlined. It'll make it easier when we change these to sines and cosines when we get to second semester. So it's worth a try. All right, now we're on solving equations. So to solve each rational equation, you are allowed to clear fractions. Excuse me. But remember to look at x is not equal to whatever. So I'm going to start by doing that. So x cannot equal 0 or 3. If I get either of those in my final answer, I throw that answer out. Okay, now take a look at the problem before you get started. 3 minus x, we can turn that around. Sometimes it makes things easier to do that. So let's make this 10 over x minus 12 over x minus 3. So the reason that happened is because I'm factoring a negative out of 3 minus x. So it becomes plus a negative or just minus. And factoring a negative out makes the x positive and the 3 negative. Now, I want to clear the fractions by multiplying both sides of the equation by the common denominator, which is x times x minus 3. Do that on both sides. So now this becomes 10 times x minus 3, which is 10x minus 30, minus 12 times x, plus 4 times both things, because 4 did not have any sort of denominator, equals 0. Now we need to get rid of our parentheses. Let's combine a little bit. This is negative 2x minus 30 plus 4x squared minus 12x equals 0. So this one's quadratic. We've got 4x squared minus 2x minus 12x, so minus 14x minus 30 equals 0. Let's divide by 2, or factor 2 out, whatever. Always try to factor first. If I have larger numbers, I do not want to do quadratic formula and work with huge numbers that I'm probably not going to correctly simplify. So try this first. Break 15 into 5 and 3. We're trying to get 7. Remember, whatever you put out here is going to get multiplied by 2. So if I put the 5 out here, that makes 10x. If I put the 3 here, 10x and 3x will give me negative 7x if I make it plus 3 minus 5. What are the solutions? You don't get anything from the 2 you factored out. Here you get x equals subtract 3 divided by 2. Here you get x equals add 5. Neither of those are the excluded values from the domain, so that's my solution. All right, I don't have anything to fix on the first one. I can get right down to multiplying by the least common denominator. Oh, but let's go ahead and say x can't equal subtract 7 divided by 2 or negative 3. If I get either of those answers, I throw them out. Otherwise, we're multiplying by 2x plus 7 times x plus 3. All right, so this first fraction, we'll have x times x plus 3. This one, be careful here with the subtraction. Minus parentheses, x plus 1 is already up there. The x plus 3's will cancel, but x plus 1 will get multiplied by 2x plus 7. And on the other side of the equals, there is no denominator here, so we're going to have to do 2x plus 7 times x plus 3. Again, be careful on your computations here. We can do this math. We just have to be careful about it. X squared plus 3x. Save the negative to distribute through at the end. So this is 2x squared minus 7x plus 7x plus 2x, so plus 9x. 1 times 7 is plus 7. On this side, 2x squared minus 6x. Why do I say minus? Plus 6x plus 7x, so plus 13x. 7 times 3 is plus 21. Let's distribute this negative and combine some terms. So x squared minus 2x squared is negative x squared. 3x minus 9x is minus 6x minus 7 equals, didn't do anything over here, just copying it down. I like my x squared to be positive if I'm going to try to factor it. So I'm going to add x squared over here, so 3x squared. I'm going to add 6x over, so plus 19x. And I'm going to add 7, so plus 28. No GCF, but let's break 3x squared into 3x and x. If I'm guessing for my numbers, I'm just going to break the end number into like smaller factors. Like I don't want to do 28 times 1 or 2 times 14. I want to do 4 and 7. And I just, again, have to kind of trial and error a little bit. Remember, whatever you put out here gets multiplied by 3. So if I put 4 out here, that's 12x. If I put 7 here, 12x and 7x will give me 19x if they're both positive. And then I solve. X equals negative 7 divided by 3 or negative 4. Neither of those are the excluded values, so both of them are answers. All right, take a look at 11. Always factor first. I can factor a 6 out of this. That's all the factoring I can do. But keep an eye out for that. If I give you a GCF in an equation, there's a pretty good chance that you could reduce and have smaller numbers to work with. 6 over 6 is 1, so we can change the problem to 1 over x minus 1 plus 1 over x plus 2 is equal to 5 over 4. Let's make a note of the excluded values. X cannot equal 1 or negative 2. The 4 is not an excluded value. It's not an x. It's a constant. We can wipe out the fractions by multiplying by 4 times x minus 1 times x plus 2. So don't forget about the 4. You want to get rid of that as well. And we're doing that on both sides. So for the first term, the x minus 1 would cancel, and you'd be left with 4 times x plus 2. Plus, here the x plus 2 would cancel, so 4 times x minus 1. On the other side, the 4's would cancel, so you'd still have a 5 up there, times x minus 1, x plus 2. Let's get rid of our parentheses. So 4x plus 8 plus 4x minus 4 equals 5 times. You should always distribute the binomials together first and then distribute the monomial through last. X squared plus x minus 2. Let's distribute that 5 through as well. 5x squared plus 5x minus 10. On this side, let's combine terms. We have 8x plus 4. This is quadratic, so get it equal to 0. 5x squared, subtract 8x, so minus 3x, subtract 4, minus 14. Let's factor. 14 is probably 7 and 2, right? If I put 7 out here, I'm going to get 35, so that's not going to work. But if I put 7 here and 2 here, I get 10x and 7x. That will give me negative 3 if I make it plus 7x minus 2 to get minus 10x. So x equals negative 7 over 5 and positive 2. Again, neither of those are excluded. Negative 2 is excluded, but not positive. Here we can factor this denominator a bit. It's a difference of squares. That shows me that x cannot equal plus or minus 2 for my excluded values. There's nothing to reduce here, so I can get right down to multiplying by the least common denominator, which is x plus 2, x minus 2. So for this one, the x minus 2's cancel. You get x plus 5 times x plus 2 equals 5 times, now the x plus 2's cancel, so x minus 2, plus 28 because the x plus 2 minus 2 canceled. FOIL a bit. X squared plus 7x plus 10 equals distribute 5x minus 10 plus 28. How about we make that plus 18? Get this equal to 0 again. X squared plus 2x. If I subtract 18, I get minus 8 equals 0. That's an easy factoring. X plus 4, x minus 2. X equals negative 4 and 2. Here's one where we finally say, but x can't equal 2 because it's extraneous. Okay, so 4 was the only solution. Okay, final thing, inequalities. For rational inequalities, you have to keep the fraction. I've tried to emphasize this over the last few days. You cannot multiply the denominator away because it will change some of your solution set. You might get part of the right answer, but you will not get the whole correct answer. All right, so first one is already compared to 0. We get right down to saying, well, x plus 5 equals 0. So x equals negative 5. X minus 2 equals 0, so x equals 2. The negative 5 is an x-intercept. It came from the top. It's going to be plotted with a closed circle because this says greater than or equal to. The x equals 2 is a vertical asymptote, meaning you can't divide by 0. It's a place where this doesn't exist. So we plot it with an open circle because the graph might change signs on either side of its vertical asymptote. Plot those two things on a number line, so put them in the correct order. Negative 5 and then 2. All right, and then test into your number line. So when you're testing, you're picking a number in each section and you're testing back into this fraction to see if it comes out positive or negative. So I'm going to plug in -6, for example. I get -6 plus 5 is -1. -6 minus 2 is -8. A negative divided by a negative is a positive. So any number in that section is going to come out positive. Between -5 and 2 is 0. So I get 5 over -2. If I plug 0 in here, that's negative. And if I plug in 3, I get 8 over 1. That's positive. Which intervals do I want? The ones that are positive, because we want to know when is this fraction greater than or equal to 0, so positive. In interval notation, my answer is -infinity to -5 with a square bracket, parentheses on 2 to infinity. This next one is also a single fraction, so all I need to do is factor it a little bit. It's going to be x plus 4, x minus 1 over x plus 2, less than or equal to 0. So we want negatives this time. I can get my solutions. So from the top, x equals -4 and +1, plotted with closed circles because this is less than or equal to. So these are the values that make the fraction equal to 0. From the bottom, x equals -2. Since you can't divide by 0 here, that's going to get plotted with an open circle. Put my number line over here. Get them in the right order. -4 is farthest left, then -2, and then +1. We have 4 sections to test in our number line here. So let's start far left. I'm going to put in -5. Test into the factored version. It's usually easier. So like -5 plus 4 is -1. -5 minus 1 is -6. -5 plus 2 is -3. This is a positive over a negative, so it's overall negative. Plug in -3. Into the factored version, you get -3 plus 4 is 1. -3 minus 1 is -4. -3 plus 2 is -1. A negative divided by a negative is positive. Plug in 0. 4 times -1 over 2. It's negative. Plug in 2. 6 times 1 over 4, positive. These signs will often alternate, especially if none of these parentheses are squared or to an even power, then you're going to have alternating signs. But if you rely on that and you mess up your first one, then all the other ones are incorrect. Then you get a lot of things wrong instead of just doing the math and double checking. I want the negatives because this was less than or equal to. So my solution set is -infinity to -4, square bracket, parentheses -2 to 1, square bracket. All right, last two. So for these two, the fraction is not being compared to 0. So first you have to do that. So x plus 4 over 2x minus 1, we will subtract 3. And remember, when you subtract 3, you have to get a common denominator. So I'm going to go ahead and set that up. And then we need to distribute a -3 through. So put this whole thing over 2x minus 1. So we would have x minus 6x, so -5x. 4 plus 3 is +7. So we get some kind of ugly numbers, but x is equal to subtract 7, divide by -5. That's +7/5. That's going to be closed circle. And x is equal to add 1 divided by 2, +1/2, open. So 1/2 would be to the left of 1 2/5, or 7/5. Even though these are fractions, the numbers between them can be whole numbers. Like 0 is to the left of 1/2. Plug into this, you get 7 over -1, negative. What's between 1/2 and 1 2/5? 1. -5 plus 7 is 2. 2 minus 1 is 1, so that's positive. And what's bigger than 1 2/5? I would just do 2. -10 plus 7 is -3. 4 minus 1 is 3. That's negative. We want negatives because this is less than or equal to 0. So solution set is negative infinity to 1/2, square bracket 7/5 to infinity. What about on 16? Same thing. You cannot cross multiply. Remember, you have to keep the fractions. So first, let's get the x's on the left side. I always move them to the left because then greater than 0 will always mean positive. Less than will always mean negative. You have to flip it if you have your x's on the right. We need to set up a common denominator, which is x plus 1, x minus 1. You need this to be one fraction before you can start testing numbers. The 1 will get multiplied by x minus 1. The minus 2 will get multiplied by x plus 1. So what's that going to be? The bottom is still x plus 1, x minus 1. X minus 2x is negative x. Negative 1 minus 2 is minus 3. So if you add 3 and divide by negative 1, you get x equals negative 3 from the top and plus a minus 1 from the bottom. Both of these are open circles on this one because this is just greater than, not greater than or equal to. So we're not including the x-intercept in our answer. Get all of these on the number line. Negative 3 is farthest left, then negative 1, then positive 1. And test a bunch of numbers. So negative 4, we're testing into this one. That becomes positive 4 minus 3, which is 1, over negative 4 plus 1 times negative 4 minus 1. 1 over 15 is positive. Plug in negative 2. That becomes positive 2 minus 3. And then negative 1 times negative 3. A negative divided by a positive is negative. Plug in 0. Negative 3 on top. 1 times negative 1 on the bottom. That's positive. And then 2. Negative 2 minus 3 is negative 5. 3 times 1. So negative 5 over 3 is negative. I want positives because this is greater than. So the solution set is negative infinity to negative 3 and negative 1 to 1. Parentheses all around because this was only a greater than problem, not greater than or equal to. There are a lot of details in all of these problems. Study the directions. Be careful on your computations. Try not to rush things, but you do want to work efficiently. And practice as much as you can.